Question 2. The masses in grams of plums of a certain kind are normally distributed with a mean of 55 and a variance of 18. A. Find the probability that a plum chosen at random has a mass between 50 and 60 grams. For this question, we simply just plug this in on our calculator. It's just 1 mark. So all we need to do here is go to Menu and 7, and we want normal CD. It's between 50 and 60, so we put a lower limit of 50 and an upper limit of 60. A few people on this question got a little bit confused with the things that you would do with discrete data, or even when we use continuity corrections. But that's only for when we have discrete data. For binomial, would we change the 50 and the 60? Or if we've got continuity corrections, that's only when we're going from binomial to normal. Here, keep it nice and simple. Lower bound is 50, the upper bound is 60. The standard deviation is the square root of 18, so be careful there. And the mean is 55. So plug that in, and for A, we get 0.761. Make sure that you write this to 3 significant figures, otherwise you won't get that mark. Okay, and it's just 1 mark, so it's either going to be correct or incorrect. Part B, the heaviest 5% of plums are classified as extra large. Find the minimum mass of the extra large plums. So we're talking about the heaviest 5%. So that's going to be in this upper region here. Okay, so we've got 55 there. And we're looking for this top 5%. So this is going to have an area of 0.05. We need to find out what value would you need to be in that top 5%. What's the minimum value you would need to be in that top 5%? So because we're trying to find a value, we're going to go Menu 7 again, but this time we're going to go for inverse normal. Now, I wouldn't put 0.05 in as my area, because that will tell me the bottom 5%. Remember, your calculator, when you're dealing with the area, it's always telling you the area to the left. So therefore, instead of thinking about 5% to the right of this value, I'm going to think about 95% to the left of that value. So I put in area 0.95, I put in the standard deviation as the square root of 18, and keep my mean as 55. When I do this, I get 61.98. So to 3 significant figures, this will be 62.0 grams. Okay, and yet again, put that 0.0 so you've gone to 3 significant figures. Part C was the question that was a lot more difficult. And I'm going to show you 2 different ways that you could approach this. The plums are packed in bags, each containing 10 randomly selected plums. Find the probability that a bag chosen at random has a total mass of less than 530 grams. So now we've got these 10 randomly selected ones. So this isn't the whole population. This is a sample. So I need to consider now that X now is not just, I'm not just going to write X, I'm going to write X with a bar across it to show that I'm talking about the sample here. And the mean will still be 55, but because I'm talking about a sample, the variance is now the population variance of 18 divided by the number in my sample, so divided by 10. So it's important to note that when we're talking about a sample, we need to divide by the number in that sample for our variance. So then I'm going to work out the probability that in that sample, now I've got 10 of these selected plums, and you're looking at the total mass being less than 530. What that means is I need to work out the probability that in my sample it's less than 53. Okay, so just 530 divided by 10. So then in our calculators, we'd use normal CD, we put in, I'll show you here, a lower limit, let's just pick something like minus 10,000, put in 53. The standard deviation will be the square root of 18 divided by the square root of 10, and the mean is still 55. When I do that, I get 0.0680, and that would be my answer there. If you didn't like that method, I do have a different way I can show you. Firstly, instead of looking at an individual plum, you can look at all 10 of them. So the mean should be 550. Okay, so if one plum has a mean weight of 55 grams, all 10 would have a mean weight of 550. Now, when we are looking at our normal distribution, you might want to write sigma x to show that you're talking about the sum of all the plums here. So instead of writing x, I'm going to write sigma x because I'm adding all 10 of these together. I've got a mean of 550, and now my standard deviation, my variance, my variance would be 180. So rather than use a variance of 18, I would use a variance of 180 now. So I need to multiply the variance by 10 as well, which is multiply the mean by 10. I need to also multiply the variance by 10. So then work out the probability that the sum of all the plums would be less than 530 grams. And put that in your calculator, and you should also get 0.0680.